Good morning, dear student. In today's lecture, we discuss the bridging modes of these carbonyl ligands. So, in previous lecture, we already discussed the bonding of carbonyl with metal atom, and we know that this carbonyl is most commonly found as a terminal ligand. So, and we also discuss the factors affecting on pi back bonding. So, up to this, we know that this carbonyl is most commonly found as a terminal ligand attached to a single metal atom. But in many cases, this carbonyl forms the bridges between two or more metals. So you should remember that it is not only act as a terminal ligand, it will also act as a bridging ligand. But the electron contribution in terminal as well as bridging forms is same. So the first point is this carbonyl is commonly most commonly found as a terminal ligand terminal ligand attached to attached to single metal atom, but in many cases in many cases in many cases this CO forms bridge or bridges this CO forms bridges between two or more metal atom metals. So carbonyl is most commonly found as a terminal ligand attached to a single metal atom. When it is attached to only one metal atom, then it is considered as a terminal ligand. But in many cases, this carbonyl forms a bridge between two or more metals. Let us discuss some pictorial representation for this bridging mode of this carbonyl ligands. So, if we consider this, so consider this metal having d orbital. Same is metal. Here the carbon is there. The oxygen is there, and these are the orbital is there. Okay, and this is the electrons, the lone pair of electrons on this carbon. So it will donate one electron to this metal d orbital and one electron to this metal d orbital, and we know that it is act as a sigma donor. So this is your sigma donor, and the bond which is formed is sigma bond. Similarly, we know that this carbonyl also act as a pi acceptor ligand. So there is a back bonding concept we already discussed. So we will show in this way, that is metal. So metal having d orbital, okay. So this is again your carbon, the carbon having empty pi star orbital, this carbonyl having empty pi star orbital, and the donation of electron, that is called as a back bonding from metal d orbital, filled metal d orbital to empty pi star orbital of this carbonyl. And there is oxygen is also, oxygen also having its orbital. This is the pictorial representation. So this is your pi acceptor. So first it is act as a sigma donor, and the second it is act as a pi acceptors. So this is the bridging mode of carbonyl. So up to this we know that the carbonyl, it will donate its electron to a single metal atom, and it is act as a terminal ligand. But in many complexes, this carbonyl also act as a bridging ligands, and it will bridge between two metal atoms or more than two metal atoms. And sorry, it is bridge between two or more metal atom. And in both the cases, that is in terminal as well as in bridging case, its electron donation does not change. So it is two electron donor, two electron donor, two electron donor in both the case, that is in terminal case as well as in bridging case. But what happened due to this bridging mode of carbonyl on this carbonyl stretching frequency? So we will discuss it. This bridging modes of carbonyl strongly correlated with the position of CO stretching band. We know that we already discussed the phenomena such as back bonding. So if there is a two metal atom and the carbonyl is bridge between two metal atom, then both metal atom involve in back bonding, and therefore the carbonyl stretching frequency is decreases. So bridging mode strongly correlated with the position of carbonyl stretching frequency or carbonyl stretching bands. If you consider in case in which carbonyl bridge two metal atom, both metals can contribute electron density into the pi star orbital of carbonyl, and to weak the carbon oxygen bond and lower the carbonyl stretching frequency. So you should remember, in case of bridging mode, that is in case in which carbonyl bridge between two metal atom, carbonyl bridge between two metal atom, both metal atom contribute electron density to the pi star orbital, empty pi star orbital of carbonyl. Both metal atom contribute electron density to the empty pi star orbital of carbonyl, and weaken the carbon oxygen bond, weaken the carbon oxygen bond. As carbon oxygen bond is weak, the stretching frequency is also decreases. So these are the two important points. That is, bridging mode is strongly correlated with the position of carbonyl stretching band or the position of carbonyl stretching frequency. So in case in which carbonyl bridge between two metal atom, both metal atom contribute electron density, that is both metal atom involve in back bonding, and the donation of electron from metal d orbital to the pi star orbital of carbonyl, and it results into the weakening of carbon oxygen bond, and the carbonyl stretching frequency is also decreases. Stretching frequency for doubly bridging carbonyl is much lower than the terminal carbonyl. The third important point is that, so we know that as back bonding increases, carbon stretching frequency decreases. Therefore, the stretching frequency stretching frequency for doubly bridging means the carbonyl is bridge between two metal atoms. For doubly bridging carbonyl, carbonyl is much lower is much lower than the terminal carbonyl than the terminal carbonyl. So this is the important point. So stretching frequency for doubly bridging carbonyl is much lower than the terminal carbonyl. Let us discuss the types of bridging and the carbonyl stretching frequency. The types of bridging and the carbonyl stretching frequency, or the types of CO, either it is terminal or bridging. Types of CO and the carbonyl stretching frequency, it is in per centimeter. Carbonyl stretching frequency, it is in per centimeter. So the first case is free CO. Free carbonyl is there. So free carbonyl means what? Free carbonyl means what? It is not attached to the metal atom. Free carbonyl, the first case is what? Free carbonyl means it is not attached to the metal atom. And if you see its carbonyl stretching frequency, that is free carbonyl stretching frequency, it is 2143 per centimeter. 2143 per centimeter when it is not attached to the metal atom. This is the carbonyl stretching frequency for free CO. Second, when it is attached to the one metal atom, that is metal atom and carbonyl. So this is the terminal mode of binding. So this carbonyl, when it is act as a terminal ligand, so when it is attached to only one metal atom terminal, then its frequency is 1850 per centimeter to 2120 or 2121 per centimeter. When it is act as a terminal ligand, then its frequency is from 1850 to 2120 per centimeter. Third one, that is when it is act as a bridging ligand. So this bridging ligand, it is denoted by symbol mu, that is mu to CO. What it indicate? This carbonyl is bridge between two metal atoms. If there is a mu 3 CO, then the carbonyl is bridge between three metal atoms. So you should remember, whenever there is a mu, what it indicates? The carbonyl is in bridging position. So the second point is metal and carbonyl. That is the bonding of carbonyl with metal, but this carbonyl act as a terminal ligand, and we will discuss the carbonyl stretching frequency. When it is bridging form, that is mu 2 CO, means it is attached to two metal atom, two different metal atom, that is metal, carbonyl, metal. So we know that both metals are involved in back bonding, and therefore the carbonyl stretching frequency is decreases, and it is up to 170. It is up to 1700 to 185 per centimeter. 185 per centimeter when it is bridging. So mu, what is the meaning of mu? What is the meaning of mu? Means the carbonyl is in bridging form, or it is in bridging position, and it is attached to two metal atoms. The next one is mu 3 CO. Mu 3 CO, what it indicate? The carbonyl, it will bridge between three metal atoms. So this is metal atom, carbonyl, metal, and carbonyl. So It is a bridge between three metal atoms. So the carbonyl stretching frequency is also decreases because three metals atoms are involved in back bonding, and therefore its carbonyl stretching frequency is 1600 to 1700 per centimeter. 1600 to 1700 per centimeter. So this is a very important point regarding to our syllabus, that is bridging mode of carbonyl. So you should remember both the terminal and the bridging modes of this carbonyl. In both the cases it is act as a 2 electron donor, but due to the bridging mode, if the carbonyl is present in bridging mode, and due to this more metal atoms are involved in back bonding, the carbonyl stretching frequency is decreases. The carbonyl stretching frequency is decreases when the CO acts as a bridging ligand. So this is all about the bridging modes of carbonyl. In next lecture we will discuss the ligand similar to the carbonyl. Thank you.